Welcome to this lesson. In this video, I'm going to learn how to find the domain of vector functions. Okay, so let's look at how we are going to do this. So first of all, I have some examples here which we are going to try our hands on. So I have these multivariable functions here, and then we have to determine the domain of these functions. Okay, so let's look at this. The domain of a function refers to the set of values that are allowed to be plugged into the function. Okay, so any value that you can plug into these functions to get an answer is part of the domain of what the function. So let's look at this. So for this function here, okay, that's the first function, which is f of xy equals the square root of x plus y. Okay, so for this function here, we are going to find its domain. So one thing you have to know is that we can't take the square root of negative number. Okay, we can't take the square root of a negative number. So let's keep that in mind. But we can take the square root of 0. Okay, let's have that in mind. So what then will be the domain for this function? So the domain for this function will be x plus y, okay, should be greater than or equal to 0, because we can take the square root of 0, and then we can take the square root of what positive numbers, but we can't take the square root of what negative numbers. So x plus y should be greater than what 0. Let's look at the second function. We have f of xy to be equal to the square root of x plus the square root of what y. So same thing as the first question, we cannot take the square root of negative number. So for the first part, root of x should be greater than or equal to 0. Okay, and then y should also be greater than or equal to 0. Now let's look at the third function. So for the third function, we have f of xy, which is equal to the ln of 9 minus x squared minus 9y squared. Okay, so you have to find the domain of this function here. One thing you have to know is that we can't take the domain of, sorry, you can't take the log of a negative number, and then you can't take the log of what 0. So what that means is that 9 minus x squared minus 9y squared should be greater than 0. Okay, so if you have this in mind, I can write this inequality here. Okay, so let's look at what I'm going to do. I'm going to subtract 9 from both sides. Okay, and then that will give me minus x squared minus 9y squared being greater than what? Minus 9, right? And then I'll multiply by negative 1 to get rid of the negative signs here. So I'm going to have x squared plus 9y squared being greater than what? 9. Okay, but because the sign for the variables have changed, then I'll have to change the symbol here to less than 9. Okay, this is what you have now. Okay, so from here, I will try and then divide through by 9 so I can get rid of this 9 here, right? So I'll do divide by 9, divide by 9, then divide by 9. So we can cancel out this 9, we can cancel out this 9. This can also cancel out. So then we are going to have the domain to be x squared divided by 9, okay, plus y squared being less than what? 1. Okay, you can choose to leave your domain here. That is if you have this answer in the answer that has been given or in the options. But if you don't have that, then you can further simplify it to this form. So with this understanding, let's look at what vector functions are and then learn how to find their domain. So what are vector functions? Okay, I'm going to write down a function, and then that will be a representation of a vector function. So let's look at that. Okay, so this function here that I have here is known as a vector function. Okay, this is a vector function in 3 dimensions. Okay, I can have a vector function in 2 dimensions. Okay, so in this case, we're going to have f of t, comma g of t. Okay, this is for the case of a 2 dimension. I can write this as equals f of t I, okay, plus g of t j plus h of t k. Okay, if I write it this way, then I will not have to bring this bracket symbols. So let's take note of that. So you're going to learn how to find the domain of what vector functions. Okay, so let's go ahead and look at that. So I'm going to take the first example here. Okay, so the first example I have here is I of t. Okay, the vector function of t being equal to 3 tan t. Okay, 3 tan t, and then comma 4 sec t, and then also 5t. Okay, so one thing you have to know is that for these vector functions here, okay, the other functions or the sub functions that are in the vector functions are known as the component functions. Okay, that's f of t, g of t, and then h of t, okay, are known as the component functions. So for these component functions, okay, the first one, which is f of t, will be for the x component, the g of t will be for the y component, okay, and then the h of t will be for the z component of the vector function. So how this vector function is, we have to find the domain of this vector function. So for us to be able to find the domain of this vector function, we must first consider the component of what the functions. Okay, so the first component, which is the x component, will be 3 tan t. Okay, and then the second component y, which is the 4 sec t. Okay, and then the third component, which is the z component, will be 5t. Okay, so first of all, we are going to find the domain for the first two component function, which is 3 tan t and then 4 sec t. Okay, so let's look at that. So for 3 tan t and then 4 sec t, okay, this function will not be defined for odd multiples of pi on 2. Okay, this will not be defined for odd multiples of pi on 2. So let's take note of this. I'm going to explain this statement, not defined for odd multiples of pi on 2. Okay, so what that means is that if you consider t, okay, to be equal to any odd number multiplying pi on 2, then substitute into this function here, then you're not going to get an answer. Okay, so in that case, I'm going to write a general form for this domain. Okay, so I'm going to say that you want t not to be an odd multiple of pi on 2, right? So the general form to write odd numbers is 2n plus 1, okay, where n is any integer. So if I substitute any integer here, I'm going to get an odd number as an outcome for this formula that we have here. Okay, so what that means is that for any number of n that we substitute here and then we multiply by pi on 2 and set to equal to t, we're not going to get an answer. Okay, so in general form, we're going to write it as 2n plus 1 multiplying pi on 2. Okay, so this will be the same as 2n plus 1, okay, pi on 2. Okay, so what this means here is that if we set t to be equal to this expression here, 2n plus 1, okay, multiplying pi divided by 2, then these two functions, which is 3 tan t and then 4 sec t, are not going to be defined. We can try that. Let's set our calculator to radians and then see what will happen. So first of all, let's consider n to be equal to 1. Okay, so we are going to have t to be equal to 2 multiplying 1 plus 1, right, divided by 2 multiplying pi. So from what you have in the bracket, you're going to have 3 divided by 2, okay, multiplying pi, right? So let's substitute this into this function, 3 tan t. Okay, 3 tan t, so that would be 3 tan of what? 3 over 2 pi. Okay, so let's try and see if we can get an answer for this. So 3 tan 3 over 2 pi. this will give me no answer. Okay, so that's what this means. So t can be any value except this general formula here. So you can say that t can be any value except 2n plus 1, okay, multiplying pi on 2, okay, where n is any integer. Okay, so what you are going to do is that you are going to write a domain for this vector function now. Of course, for this third function, it will be defined for any value of t that we put inside. Okay, so any value of t that we put in this 5t here, we are going to get an answer. So therefore, the domain for the function, okay, let me have some space. Let me have some space here. Okay, so the domain for this function here, okay, the domain of the function, the vector function r of t, okay, will be t, okay, such that t should not be equal to 2n plus 1 pi, okay, divided by 2. So we can consider t to be any number except 2n plus 1 over 2 multiplying pi. So that will be the domain for this function. Let's take one more example. So I have another example here. Okay, we have to determine the domain of these functions here. So we have the vector function which has component functions, right? So the first component function, which is the x component, will be the cosine of t. Okay, and then the y component function will be the ln of 4 minus t, and then the z component function will be the square root of t plus 1. So we are going to find the domain of what each of these components function. For cosine of t, it will be defined for all t values. Okay, so this will be defined for all t values, which means that any real number that you put here in the cosine function, you are going to get an answer. Let's look at that of the ln of 4 minus t. So for ln of 4 minus t, okay, we know that you can't take the log of a negative number and also the log of 0. Okay, so what that means is that 4 has to be greater than t, or t has to be what less than 4. Okay, as soon as t becomes greater than 4 or t becomes equal to 4, then you're going to get an undefined answer. Okay, for example, if we set t to be equal to 4, then we are going to have ln of what 4 minus 4, and then that's what ln of what 0. Okay, and that's undefined. And then if we set t to be equal to a number bigger than 4, then we're going to have ln of what 4, let's say 4 minus 5. You know 5 is bigger than 4, then we're going to have ln of what negative 1, which is what undefined. Okay, so t must always be less than what 4. That's for the second function. Let's look at the third function. So for the third function, that's what square root of what t plus 1. Okay, we know that we can't take the square root of what of a negative number. Okay, we can't take the square root of negative number. So if we let's reset t to be equal to -2, okay, I'm going to have the square root of what -2 plus 1, right? That will be the square root of what -1, and we can't get an answer for this. Okay, that will be in complex form, but that's not what we need. Okay, so we must not make this t plus 1 be a negative number. Now let's try t equals -1. If t equals -1, you're going to have -1 plus 1. That's going to give a square root of what 0, which is what 0. So when you set t equals -1, you got an answer. Okay, and then if you set t to be equal to 0, 1, 2, 3, going, you are all going to get answers. But if you set t to be equal to a number less than -1, then you are not going to get an answer. So in that case, you are going to say that the domain should be t. Okay, this should be greater than or equal to what -1. So any value of t which is greater than or equal to -1, if you substitute it into this function here, you're going to get an answer. So let's look at what we have now. So we have two different domains here. Okay, we have this domain here, we have this domain here, and then for the first one, it is defined for all values of t, so we shouldn't worry about that one. So let's consider these two domains that I have here. Okay, we have for greater than t, and then t should be greater than or equal to -1, right? So let's look at what you are going to do now. So I'm going to combine these two domains. Okay, so to do this, I'm going to rewrite this one as t is less than 4. Okay, it is the same thing. So let's combine these two domains here. So I'm going to have t less than 4 and then greater than or equal to what? -1. So I just combine these two domains to get this domain that I have here. So this will be the domain for the vector function. You don't have to worry about knowing how to get the domain. Okay, I normally use one chart that I got from Google. So you can search for domain of functions. Okay, you can choose to search for domain of uh, trig functions, or the domain of, if you search for domain of functions chart, I'm sure you're going to get that picture, and then that will help you in solving this kind of questions. Thank you very much for watching this video. Please make sure you like and subscribe.